Hello everyone. In this lecture, we will use MATLAB to analyze the discrete time signals and systems. First, we use MATLAB to do partial fraction expansion. And then we will use MATLAB to get the poles and the zeros and system properties. We can use MATLAB to do the partial fraction expansion. This is a MATLAB function. Here, the input parameter num and den are coefficient vectors of numerator and denominator, respectively. R1, R2 are expansion coefficients, and P1, P2 are poles. If x of z is a proper rational function, then K1, K2 equal 0. For example, if we have this x of z, we can get the input parameter num and den. Use this MATLAB function, we can get the result R, P, and K vectors. According to the output parameters, we can get the expansion for this x of z. According to this x of z, we can get its x of k by the inversion of unilateral z transform. We can use this MATLAB function to get the impulse response for this system. Here, the input parameter num and den denote the numerator coefficients and denominator coefficients. A denotes the output number, and H is the impulse response for this system. By this MATLAB function, we can obtain the pole zero plot for this transfer function. For example, depict the pole zero plot and determine the impulse response and frequency response of the causal LTI system. According to this H of z, we can get these MATLAB programs. Use these MATLAB functions, we can get the result. This is a pole zero plot. This is a impulse response. This is a magnitude frequency response. Now we will find the impulse response according to the poles and zeros. If the pole moving along the real axis, we will find the result. The poles moving along the real axis, the impulse response will change according to the pole's position. If the pole moving along the imaginary axis, we can find the impulse response will change with the pole moving. When the poles and zeros move in the z-plane, the impulse response will change. So we can use the MATLAB functions to analyze the response and the zeros and the poles for the system transfer function. That's all for today. Thank you.